Hey guys, this side Mayank, and this is my MLOps project about US visa approval prediction. Coming to the problem statement, every year thousands of US visa applications are filed, but not all of them get approved. The decision depends on several factors, including the applicant's education level, job experience, and even the employer's credibility. So we had the set of features related to the applicants and the company. The goal is to predict whether a visa application will be certified or denied. So first, let's see what the end user is going to interact with. Here is the Streamly tab, basically the front-end UI. Here, the applicants have to fill in these details, such as from which continent they are, and then the region where they are going to get the employment. Then select the education qualification, the prevailing wage, the unit of the wage, and whether they have a job experience or not. Also, whether they require training or not. Here we have to select whether we are going for a full-time position. For the number of employees, we need to enter the number of employees in the company we are going to work in. And lastly, the age of the company. Let's click on predict and you can see we got an output that the applicant's visa is not approved. The output is according to the set of inputs that we have provided. Okay, so let's look at the architecture of the project. The data is coming from the MongoDB database. Here, I am in the MongoDB dashboard. You can see in the US visa collection, we have the data. As you can see, we have all the feature columns and the target column is case status. So moving on, we have the data ingestion component. The data ingestion component is responsible for loading raw data from the source, which is MongoDB for this project, and configuring ingestion parameters like file paths and train test split ratio. It exports the data to the feature store for accessibility, splits it into training and testing datasets, and stores these output as CSV file in the artifact directory for downstream processes. Moving on in the architecture, we have data validation. The data validation component ensures the integrity and quality of the ingested data by verifying the number, type, and completeness of the columns in both training and testing datasets. It checks for missing numerical or categorical features and detects any dataset drift. A validation report is generated highlighting the errors or drift, if any, ensuring the data meets the required standards for model training. After that, we have data transformation. This component preprocesses raw data by applying encoding, scaling, and transformation techniques. It handles missing value and data balancing using SMOT, outputting transform arrays, and preprocessing object for the model training. The next component is model training. This component uses transform data to train and evaluate multiple models, selecting the best performing one based on the accuracy threshold. It outputs the trained model along with the performance metrics and artifacts for the further use in deployment. Alright, let's move to the next component, which is model evaluation. After that, we have model pursuit. This component finalizes the deployment process by saving the trained model and pushing it to the specific S3 bucket. This ensures that the model is accessible for real-world uses through the US visa estimator system. And then the final model artifacts, such as the trained model pickle file, which are stored securely in the AWS S3 bucket. So here I am in the AWS console. Let me go to the S3. Here is the US visa bucket, and inside that you can see the final trained model.pickle file that can be used to predict the approval status. Coming back to the architecture, next it will use Docker to containerize the application, encapsulating all the dependencies and model artifacts into a portable image. The Docker image is stored in AWS ECR. So let me go to the ECR in AWS. Here in Visa, you can see we have the Docker image that will be deployed seamlessly to the AWS EC2 instance, and this process will be automated with the help of CI/CD. So here I am using GitHub Actions for CI/CD. Let me show you the GitHub Actions. So in this repo, go to the Actions tab. Here you can see the continuous integration and continuous deployment. In the CI, you can see that it automates the entire process of building, tagging, and pushing Docker images to the AWS ECR. And in the continuous deployment, which is CD, it pulls the Docker image and deploys it on the EC2 instance. Okay, so after that, we have the Fast API as the backend, which will manage the API endpoint. Let me start the AWS EC2 instance and run the Docker image. There you go. The front-end UI is on port 8501 and the backend Fast API route is on port 8080. By the way, you can host your frontend from anywhere. Let's see if the API route is working or not. So the public IP address is this, as you can see. So let me open the Postman to check whether the API route is working or not. So here I am going to enter the predict route endpoint. In the body, we are sending the user's info. Now let's click on send. Here you can see the status is 200 and the prediction that we have got from the backend is that the visa is approved. So this was the backend and API endpoint. And then we have the Streamly tab that I have demonstrated you initially as the front-end UI. Here is the folder structure for this project. Feel free to pause the video to take a closer look. Finally, here is the GitHub repo URL. You can see the code, flowcharts, and architecture images in detail from there. Thank you for watching.